Hello guys, you are welcome to GMAETS 41's YouTube channel. So in this lecture video, I am going to teach you how you can carry out triangular prism experiment tracing without actually doing the live practical. You are going to learn how to do the construction. You can see showing the work that GMAETS 41 has done already. I didn't use pins to trace these rays of light you're seeing. I did not use pins, to trace them. Rather, I used the knowledge of geometry to be able to carry out this tracing. So the purpose of this particular lecture is to assist those who maybe they are worried about how they can carry out their tracing using the pins, maybe in the laboratory, although that is the main experimental work. However, one can still, boycott that. So I want to have you learn how that can be done, so that in case you are stuck with time, you can decide to carry out the construction format instead. Like I said, you need the knowledge of geometry. So let us get to business without wasting any further time. I am going to carry out, the tracing of incident angle of 50 degrees. Incident angle of what? 50 degrees. Already I'd worked on that of 40. I'd also worked on that of 70 degrees. You can see that. So we got the emergent angle, we got the angle of deviation, as you can see. All right, so what are the instruments you need for this purpose? You need this. This is your protractor. You need this. This is your ruler. You need this. This is your prism. The prism will be provided for you in your laboratory work. The ruler and the protractor, you are meant to come with them. Of course, you should have your mathematical set. So the first thing you have to do is to trace the outline of the prism, the outline of the triangular prism. Trace it out. So you have to place it on your plain paper, and of course, you draw out the outline. By now, all of you should know how to trace the outline of your prism, whether triangular or rectangular. So we go this way. I decide to use pen, so at least you can be able to see the outline as it is being traced. In your laboratory work, you are meant to use pencil instead. Now that I've traced it, I'll remove it. So this is what I got. You know that in carrying out triangular prism experiment, I've already done the live practical, all right? So you can watch the live practical video in order to see how that is being done live, okay? And during that practical, I mentioned the various angles that you can be asked to measure. Okay, so our aim would be to get the angle of deviation, because most times that is the focus of your examiners, okay? Please take note, in using pencil to draw, you see this excess line, you have to wipe it off. This excess line out, you have to wipe it out. So this point is labeled as A, we have this as B, we have this as what? C. Now the length AB, you have to measure it. And for what I have here, the length AB is 4 centimeters. So you need to know the middle. You need to know the what? Middle. The middle will be 2 centimeters. So I'll make a mark there. The reason is because the next thing which you are meant to do, drawing the normal. The normal is meant to be drawn on one side of the middle, one side of the center of this line AB. Okay, so I can decide to select this point and then draw my normal. Like I said, by now, I think there are lots of principles about this triangular prism that you are expected to have known already. If you have not learned about them, then take the experimental work on it. I think on this channel, under Physics 107/Physics 108, we tagged that lecture that I held on this practical work. Is it L3 or L1, thereabouts? Okay, so you can check it L3 or so, yeah. So you know how the experiment is being carried out. Once you draw this outline, the next thing is to draw your normal. And a normal is a line drawn to meet either the face AB or the face AC at 90 degrees. In your question or in the instruction, it's going to be stated, so you follow the instruction. Let us draw our normal at this point. To achieve that, I'll move my protractor. The middle point of this protractor, where the 0 to 180 degrees line met the 90 degrees line, that middle point will be placed at the point you wish to draw your normal. Okay? Then the 0 to 180 degrees line, this horizontal, will be placed on this outline AB. So let's do that and see. Make sure you place it perfectly well as much as possible. I've done mine. I've placed it. So locate this 90 degrees. This is the point of 90 degrees. Make a point there. Okay. Then remove your protractor. Bring your ruler. Join this point where you wish to draw your normal to this point. If you join both of them, you have gotten your normal. So this is the normal. Permit me to label it as N1. That's the first normal. Whatever label you see in your instruction, you follow it, okay? Now, I told you that we are going to carry out this construction, okay? This shortcut tracing for 50 degrees. How do you get your 50 degrees? Now, I want to take note of something. Your examiner can ask you to get the angle of incidence to be 50 degrees, either measured away from the normal, this way, or take note of this. It could be as measured from this line AB, something like this way. So when the question is given to you, please read very well. Read the instruction very well. 50 degrees measured away from the normal. How do you measure it? Once again, place your protractor exactly the way you got that 90 degrees. Place your protractor exactly the way you got that 90 degrees. Now, I am going to measure 50 degrees away from the normal, this way. So you see, from 90 to 80 is 10, to 70 is 20. You have this 30 to 50, you now get 40. From 90 to 50 is 40 degrees. Then from 90 to 40 is 50 degrees. So it's simple, you can count 10, 20, 30, 40, and what? 50. So at that point of this 40, that gave you 50 degrees away from the normal, you make a point. You make a point. Now let me quickly say this. If you are asked to measure 50 degrees away from the face AB, from the line AB, you place your protractor exactly this way again. Measuring that 50 degrees will now be from here. To be from here this way. Which means 50 degrees would be, watch, from this to this is 10, very clear, 20, 30, 40, and what? 50. This is where you are going to make the point. That is 50 degrees away from the face AB, from the line AB. Like I said, there are some instructions given to you where the measurement will be from the line AB. So you measure this way. But if it is from the normal, that's the one I did, which we got it to be at this point 40, measured away from 90. But it's all simple. Are you following, right? If measuring 50 degrees from 90 will take me to 40, it means that from AB to this point will give you 40. Are you following, right? Because this normal we're about to get, look at this line. This angle this way. This angle this way is 90 degrees. So if I have located my 50 degrees away from the normal, what I have to do now is to join the 2 points. Join the 2 points. So you make sure the ruler is, on them, then you join. So this is your incidence ray. This angle is 50 degrees. I equal to 50 degrees. Well, if the instruction requires that you produce, that is, you extend the incidence ray, you have to make sure that you dot it this way. Okay, dot it this way. Dot it this way. Now, the reason is because this line, the incidence ray produced, and then there is a line we're going to get this way, we call the emergent ray. That emergent ray produced, where it meets the incidence ray produced, that point we get the angle of deviation, which is one of the most important things we do, okay, or we try to get when we are carrying out experiments on triangular prism. All right, let's move on, guys. So I have joined this point of incidence to this point where I measured 50 degrees. So you take off your ruler. So what do you do next? Remember, we are trying to construct this tracing without running the live experiment. I've got to my angle of incidence. The next thing you are meant to obtain is your angle of refraction. So you need to get the refracted ray. That line that will go this way, watch, to go this way to touch this face AC before the ray will come out. You need to get that ray. And to get that ray, it's called refracted ray. Let me show you. Look at it, this ray, this line. To get it, to get this line you're seeing, you would have to determine or measure your angle of refraction. For this 40 degrees is 25 degrees here. The angle of refraction, I labeled it R1. Remember, what we are doing here is to construct this. Your examiner may not ask you to measure this angle, so you don't need to show it. But while you're trying to construct this, you need to use your pencil to show. At the end of everything, you wipe. Okay. So how do we now get that refracted ray? Like I said, we have to get the refracted angle first. To get the refracted angle, we are going to use a formula. The formula is actually Snell's law. Okay? So I'm going to write it here. Let's see. So here, we're going to use the formula that the refracted angle will be equal to sine inverse of sine of angle of incidence divided by the refractive index of the glass. Now we can use the refractive index of the glass to be 1.5. Yeah, it's good. 1.5. So if I substitute there, what are we going to get? The angle of refraction will now be sine inverse, open bracket, sine of angle of incidence. The angle of incidence is 50. Then all over the refractive index of the glass, which is 1.5. So evaluate this quantity, the angle of refraction. You need your calculator now. Press sine inverse of sine 50 over 1.5. You can press it once with your calculator if you want. Okay. Shift sine if you're using this calculator. Then sine 50. Sine 50. Right? You can see that 50 now. It was not closed. So you have to close it before you divide by 1.5. And then you close the overall bracket. So you see the bracket started from this open bracket. Before that sine inverse, after that sine inverse, there is a sine inverse there. Then sine 50 in bracket divided by 1.5. Then you close the bracket. But you can decide to evaluate sine 50 over 1.5 first. Whatever you get, you now find the sine inverse. You can do that. The choice is yours. Now let's evaluate this and see equal to. This gives 30.7. 30.7. But one thing is that your protractor, they are measured in 11 degrees. 11 degrees. So 30.7 here, we are not going to record with a point. Okay? You need to approximate the whole number. That's the point I'm trying to make. 30.7 will give us 31. So this would be 31 degrees. This would be 31 degrees. Okay? And so we are going to take our protractor now and measure 31 degrees away from this normal. 31 degrees away from this normal, because that will give you the angle of refraction. I showed it to you a moment ago. Let me show you once again. Look at it. Angle of refraction. This 25 degrees. This is the line we want to get. Look at the line we want to get. This refracted ray. To get it, you must determine the value of the angle of refraction, which I have obtained. So since I've obtained the angle of refraction, it's just for me to use protractor and measure it so that I will know where this line, refracted ray line, will pass. And this angle is measured away from the normal, like I said, okay, from this normal. So watch as I do that. I've already taught you guys how to place your protractors to measure angles. I have a unique video lesson that explains that. So I want to measure 31 degrees away from this normal. Something this way, okay? Once again, something this way. So how do I achieve that? I'm going to place my protractor. Since the angle is formed here, the middle point of the protractor, this middle point, will be placed here. Then the 0 to 180 degrees line, this horizontal, will be placed on this normal so that I can now measure this way, 31 degrees away from it. Watch. So you see that the middle point of the protractor is now on the middle point here, the point of incidence. The 0 to 180 degrees line, this horizontal, is on the normal exactly. Now you can see that. You have to make sure you place this as perfect as you can. So from here, we are now going to measure 31 degrees this way. As you are measuring this way, you are measuring it away from the normal. So 31 degrees, let's move. From 180 to 170 is 10 degrees, to 160 is 20 degrees, to 150 is 30 degrees. Then 31 is the next line away from it, which is this point. So I've measured the 31 degrees. So what I have to do now, look at it, this point, remove your protractor, get your ruler and join. Get your ruler and join. This point, you're meant to join it to this point of incidence. That will give you your refracted ray. But you are not meant to draw this from this point, because the refracted ray, if you are tracing it, is meant to just touch this face AC. So it goes this way. This is the refracted ray. Once it touches this face AC, you stop. But in placing your ruler, you must make sure you target this point and this point of incidence so that the refracted ray you're drawing will be the correct refracted ray passing through where it is supposed to pass. You cannot just wake up and then place your ruler like this and draw. It's not done. You can't just place it this way and then you draw that this is your refracted ray. You don't do that. That is why we must have to locate this point first. We measure that angle, 31 degree, and we'll find out that 31 degree measured from the normal, if the normal were to be extended this way, measure from the normal, 31 degree is going to be at this point. So you place your ruler at this point, make sure you adjust the other end of it, you can see, to pass through the point of incidence, which is this point. Okay? Let's label this point as point O, point of incidence. Then when you are trying to join, like I said, don't draw the refracted ray from outside there, don't. You take it from this point of incidence and then you move down to this face AC. Down to this face what? AC. Good. The next thing you have to do is to draw your normal here. Draw your normal. Draw your normal. So how do we get our normal at this point? Permit me to label this point as point P. Let's say I label this P here. Whatever the label given to you in your instruction, you follow through. Now to get your normal, you place your protractor similar to the way you got N1, the first normal. So the middle point will be at this point you want the normal to pass through. The 0 to 180 degrees line will be on the outline, the face AC. So it's going to be something like this. Like I said, you make sure you adjust as much as possible perfectly. So look at 90 degrees here, and that gives you the normal. I've made a point here, which is where the 90 degree line came out. So what I have to do now, remove this, and then join this normal to the point of emergence. This point is called the point of emergence because that's where the ray, the refracted ray, will come out from. So you join this point to this point. This is your normal. Check it inside. This point is called the point of emergence. Take note. I might decide to extend this normal if I want. I might decide to extend it because you might be asked to measure an angle there. Who knows? Your examiner will decide. Your examiner will do what? Decide. So let me extend the two normals so that they can cross each other. Good. So permit me to label this as N2, the second normal. All right, guys. I hope you're together, right? This angle is 31 degrees. Take note. That's what we calculated here. We're going to call it R1. Please permit me to call it R1. We calculated it already. You can see there. This angle. That's your R1. And it is 31 degrees. 31 degrees R1. You don't need to label it. You don't need to label that angle except you're asked to measure it. We measured it because we needed this angle to know where our refracted ray will pass through. So what I showed here, writing 31 degrees R1 is not necessary. It's not necessary. So now that I have drawn the normal N2 at this point of emergence, phase AC, what I now need to do is to calculate the angle of emergence. The angle of emergence would now help us to know where the emergent ray will come out through. There's a ray that's meant to come out this way. So where is that ray meant to follow? Because you cannot just wake up and place your ruler this way and then draw that line. You can't keep your ruler this way and then draw that line. You can't keep it this way thinking that you are getting the emergent ray. It's not done. You must calculate the emergent angle. Once again, look at when I worked for that of 40 degrees, the emergent angle was determined to be 67. When I did for that of 70 degrees, it was determined to be 31 degrees, the emergent angle. So you need to calculate for it. And how do we calculate for the emergent angle? You're going to use this formula to calculate for it, okay? Take note, just memorize the formula as I'm showing you this particular. The formula actually comes from Snell's law. Okay, it comes from Snell's law. Snell's law that says that the refractive index N is equal to sine I all over sine R. Anyway, let me just show you quickly why we are using that formula. See, the refracted ray here is coming out this way. Look at it. This is a refracted ray. When it hits this phase AC, it is meant to enter air. The surrounding here is air, which is a different medium from this triangular prism. So, since the refracted ray is hitting this phase AC to come out, it is going to refract outside here. It simply means we will take this refracted ray to now become the incidence ray on phase AC, such that the emergent ray will now become the refracted ray. Just like we are saying that the light is now coming out from glass. It hits this phase, which will now be taken as the point of incidence 2, because we have point of incidence 1 here. So once it hits this phase, it will now come out. We call it emergent ray. So this will now be like the incidence ray from the glass and then emergent ray entering the second medium air. And if that is the case, to calculate the emergent angle using Snell's law, we are going to say that the refractive index, refractive index will now be equal to, this is going to be refractive index of air. Let me use NA. Take note, NA. Why is that so? In my lecture videos, I had already explained and made very clear that where refraction is taking place, that is the refractive index you are going to have as subject to the formula. Remember, I told you that the refracted ray is now acting as the incidence ray at this point of emergence. When it hits this point, entering air now, that's coming out, it will now refract outside here. The refraction outside is called the emergent ray. Its angle is the angle of emergence. That's what we're trying to get. So, in all, what I'm trying to tell you now is this refracted ray we got inside here will now become our incidence ray that will now help us to get the emergent ray. So we shall call these the incidence ray inside the glass. The emergent ray will now be the refracted ray outside. So that we can now use refractive index of air where the light is entering to, where the ray is now entering. Because the ray is now coming out from glass, entering air. I've explained all this in theoretical part of physics 1 of physics. That's physics 102. You can learn more about it, okay? So I'll use Snell's law, which is sine of angle of incidence. And I told you that the angle of incidence here will now be this refracted ray. Will now be this what? Refracted ray angle. We're going to call that angle here R2. We're going to call it R2. Remember, I'm using this as R1. So let me call this as R2. So it's going to be sine of R2. Since this angle R2 is now acting as our angle of incidence as the ray is trying to come out, divided by sine the refraction outside, which is the emergence in that case. So divided by sine E, where E is the emergent angle. But we do not know the refractive index of air. We don't know it. We only know the refractive index of glass. This one, I'm using N as the refractive index of glass. In fact, permit me to put G here, subscript G, refractive index of glass. So since I don't know the refractive index of air, how can I work on this? Refractive index of air is equal to 1 all over refractive index of glass. Once again, I had treated this in the theoretical aspect of physics already under refraction. If light is traveling from medium 1 to medium 2, the refractive index of medium 1 is going to be 1 over refractive index of medium 2. If light is traveling from, let's say, medium A to medium B, and you know the refractive index of medium A, the refractive index of medium B will now be 1 over refractive index of medium A. They are inverse. Okay? So since I don't know the refractive index of A, I'll now have to go through the refractive index of glass to solve whatever I want to solve here. Our problem is to get this emergent angle. That's our problem. We get this what? Emergent angle. And to get this emergent angle, you are now going to use this part of the formula. Look at it. I could have just given you the formula directly because I've already established that. You can see it. But I just want you to see and believe. Try to understand how this formula came about. Look at it. So what I'm trying to say in essence is we now make this angle of emergence subject of the word formula. To make it subject of formula, all we have to do is cross multiply. You will get sine E equal to refractive index of glass times sine R2. Then to get E, you take sine inverse. The formula will now be, the emergent angle will now be equal to sine inverse, open bracket, this times this. Refractive index of glass, which we're using 1.54, multiplied by sine R2. So this is the formula. That's good. Take note of the formula. So memorize this. You don't need to go through all this stress. To calculate the emergent angle, it is simply sine inverse of the refractive index of glass, that's of the prism, times sine of this angle here. So we're going to measure this angle. We have our protractor. We're going to measure it so that we can do the substitution there already. I'll take my protractor. Let us measure this angle. To measure this angle, I'm going to place my protractor at this midpoint. Remember, the angle is between this line, this normal, and this refracted ray. So I'm going to place my protractor, the middle point, at this point here, okay? Let me extend this normal because I need to see where it will come out. I need to see where it will come out from my protractor whenever I am doing the measurement. You are using pencil to do this. All these extra lines here you produce out, you have to wipe it off. There is a reason why I needed to extend it. So I'll place the midpoint of the protractor here. Then the 0 to 180 line of the protractor, I'll either place it on this normal, because this normal is one of the lines that made up this angle I'm about to measure. Okay? So let's say that I placed it this way. You can see now The 0 to 180 degrees line is on the normal, and then the middle point at the point of emergence. All right, but you can't place your protractor this way. Because if you place it this way, you're going to have problem with knowing where the refracted ray that formed this angle R2 you're trying to measure. You're going to have problem knowing where it came out from. So I'd rather advise that you're going to place this protractor this way. The reason is, let the 0 to 180 degrees line pass through this line, this refracted ray. Let it pass through this refracted ray. The 0 to 180 degrees line should pass through this refracted ray. The middle point of the protractor should still be at this point of emergence, so that when you are now measuring away from this refracted ray to get this angle, look at what we're trying to get, this angle, you can be able to see where this ray came out on your protractor, so you can get the accurate value. So watch what I'm trying to do here now. This middle point at the point of emergence, then adjust it so that the 0 to 180 degrees line will pass through the refracted ray. Look at it, something like this. Good. Think I've gotten it. Perfect. Then you now measure from this point. Now look at it, because this is your refracted ray. If I were to extend it, if I were to produce it, it's going to come out here. So you are measuring from that point down to this point of the normal. So from 180 to 170 is 10, to 160 is 20. Then you notice to 150 is 30. Look at where the normal came out. And from what I can see here, it's not exactly at 150. It is just the line before 150, which is now going to be 180 to 170 is 10, to 160 is 20. Then just before 150 will be 29 degrees. It means that our R2 is 29 degrees, this R2. I will come over to this emergent angle and then fix this formula. I'll come to it. Our E will now be equal to sine inverse, open bracket 1.5 times sine R2. And we got R2 to be 29 degrees. I'm taking this thing gradually so you can be able to understand the process. This is the only one I'm working out for you. Okay, so if you can grab that and you wish to use it, instead of doing the normal tracing where you have to close your eye, you find out whether you have blocked the pins or not. If you don't want to do that, you now work on this. So I'm taking my time gradually without over rushing so that you can grasp this point clearly. Now at this point, you're going to use your calculator. Now, based on what I'm explaining, in the examination hall, in your laboratory work, you can be fast because you already know what to do. The time I wasted here, I'm not supposed to waste it. I've told you, just cram this formula. That's why you need to calculate your emergent angle, which you need to be able to get the emergent ray. So let us solve the sine inverse of 1.5 times sine 29, where R2 is equal to 29 as we measured. Are you following right? R2 is equal to 20. Let me write it here. R2 equal to 29 degrees. But R2 equal to 29 degrees. So let us evaluate it and see. We are evaluating sine inverse shift. Sine inverse. Please get used to your calculator. Some of you do not use this calculator. Learn how yours is being used. But to avoid any error, so you don't get yourself into trouble, you can decide to evaluate 1.5 times sine 29 first. Whatever you get, you now find the sine inverse. But I'm going to press it all at once. So sine inverse 1.5 multiplied by sine 29. You have to close this and close it again because of the first bracket you opened here. This inner bracket closes that 29. And then this one closes that 1.5. If you don't do this and you want to press it once, you'll get a wrong answer. So let's see what we get here. 46.6, which is approximately 47. So this is 47 degrees. It means that the emergent angle here is going to come out at 47 degrees away from the normal. At 47 degrees away from the normal. So I'm going to bring my protractor. Once again, the middle point of the protractor will be placed at this point where the angle of emergence formed at this point of emergence. Then the 0 to 180 degrees line can be placed, all right, on this normal. Then you now measure your 47 degrees. So watch as I do that. The middle point is going to be at this point, 0 to 180 on the normal. So we have something like this. Adjust the 0 to 180 to lie on the normal N2 as perfect as possible. Good. Then from here, I'm going to measure how many degrees? 47 degrees to get the emergent angle. So from 0 to 10, 20, 30, 40. Now this midpoint is 45. Okay. And then 46, 47. So somewhere here, 47. Join this point of emergence, right? That point, join it to this point here. This point, join it to this point of emergence. That will help you to get the emergent ray. So this is the emergent ray, which means if the ray of light from the triangular prism, which is our refracted ray here, if it incidents, if it hits this face AC, it is going to refract this way along this line. This angle you are seeing is your emergent angle. If you are asked to measure it, fine. You have already done the calculation. 47 degrees. Okay, 47 degrees. Now you are expected to produce this line, this emergent ray. You are expected to produce it to meet the incidence ray, which was also produced. Dot, 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 dot. What I'm trying to do here is just the general principle of triangular prism, and most times that's what they ask you to do. This angle is the angle of deviation. Is the angle of deviation. I'm using D. You can be asked to measure it, because in most cases they ask you to measure the angle of deviation, which is one of the most important parameters we really are interested in when we are carrying out experiments on triangular prism. So let us measure this angle. Let us measure it. To measure it, remember that the angle is formed at this point, the point where the emergent ray and the incidence ray produced, where both of them met. That is where this angle of deviation forms. So you are going to place the middle point of your protractor. The midpoint of your protractor will be placed on that point where the angle is formed. Then the 0 to 180 degrees line can be placed either on this emergent ray or on this incident ray, because the emergent ray and the incidence ray, both of them formed this angle. Okay, I would like to place this. I would like to place the middle point here, which of course is meant to be. Then the 0 to 180 degrees line, I'll place it on the incidence ray. So it's going to go something like this, something like this. Good. I guess it's perfectly there now. Then I will measure from this point, because this is where the incidence ray produced. This is where it's meant to come out, since it is lying on the 0 to 180 degrees line. Measure from there to this emergence ray in order to get the angle of deviation. Yes, measure from this line. This 0 to 180 degrees line represents the incidence ray produced. You can see the incidence ray. Look at it. Went this way. That's why we place the 0 to 180 degrees line on it. So measure from this point down to this line, which is the emergent ray. If you measure it, you have gotten your angle of deviation. Once again, watch. This is the angle we are trying to measure. If this line were to be produced, dot, 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 you will notice that we are measuring this angle like this, from the incidence ray produced to the emergent ray. And to achieve that, I've told you, the middle point of the protractor will be placed at this point where that angle of deviation was formed. Then the 0 to 180 degrees line can be placed on the incidence ray. Then you now measure to the emergent ray. So let me place it once again. Good. Make sure you adjust very well so you get at least near accuracy. So we measure from this to this is 10 degrees, 20 degrees, 30 degrees. Then this midpoint is 35, 36, 37. So I noticed that the angle of deviation here is 37. Please take note, I did not measure from the normal. I did not. I measured from this 0 degrees point, because that's where the incidence ray is meant to come out. So from here, 37 degrees. So my D is equal to 37 degrees. I can write it under here. I can write it here. D is equal to 37 degrees. Good. And these are the main things that you can be asked to measure. With this thing, I've completed the tracing. I've completed the tracing without running the experiment. Now, if you follow through with what I explained here, then you would have understood this concept fully. Which means you can do this in your examination hall. Don't forget the formulas you need to memorize. This one, to help you calculate this angle here, which will help you determine where your refracted ray will pass. Then the second formula, this, which will help you to calculate the emergent angle, which is this. Remember, once you draw this refracted ray and you get this your normal N2, that will help you to measure R2. So you don't have problem with getting R2, which you need to use in calculating the emergent angle. So you memorize this formula. It will help you out to get your emergent angle at this point. And you need R2. R2 can be measured with your protractor once you get the refracted ray and the normal. You need this formula to be able to get your R1 here. Okay? And you need your R1 to be able to draw this refracted ray. Good. The way I measured all these angles, you follow through. You can replay this lecture video so that you grasp all the point. Once again, of course, you have to watch at least 2-3 times. Yes, you're going for exam for those that have this exam tomorrow and this week. So you capture this very well. Remember, if you are exposed to triangular prism experiment and it is a live practical, if it is not alternative to practical, if it is live, you are going to do up to 5 or 6 traces. Are you following, right? So, I don't know. If you are going to be very fast with running the practical live, good. If you feel like constructing it to get all these rays is what you're going to do, good. I have provided both alternatives for you. I've done the live practical and I've taught you the shortcut method of how you can construct. If you're asked to measure this angle, fine. Of course, from calculation, we already got it. If you're asked to measure this angle, you can. If you have to measure this angle, you can. But for one thing, using your knowledge of triangle, since we know this angle 31, and we know this angle R2, we measured it with protractor, you can add both of them, subtract from 180 to get this angle. Remember, sum of angle in a triangle is 180. So this 31 plus this 29, which is R2. Are you following, right? R2. R1, which is 31. Plus R2, which is 29, plus this unknown, this part, will be equal to 180. So you solve for this part. And once you get the value of this angle, for example, now, this is what I'm talking about, just do 180 minus the value of R1, which is 31, minus the value of R2, which is 29, equal to 120. So this angle here is 120. This angle is 120. And with that, you can get this angle here. You can. This angle will be 180 minus 120. So here will be 60 degrees. And this is perfect. This is perfect because for triangular prism, the refracting angle is usually 60 degrees, which is this angle. Because usually most of them are equilateral, 60 degrees. Remember I told you that this angle here is equal to this angle here. Alright guys, I think this makes sense. Whatever angle they ask you to measure here, you can measure it. There is no big deal there. Remember, like I told you, you might be asked in getting your angle of incidence, instead of fixing the angle of incidence between the normal and the incidence ray, your examiner can ask you to measure the angle of incidence, maybe like this 50 degrees, and measure it from line AB. So it will be going this way, which means you are measuring 50 this way, therefore making this angle between this first normal and the incidence ray to be 40. Remember, you see this line that went this way, this normal, and this outline AB. The angle here is 90 degrees, this angle. So if here is 50, here will be 40. If it happens that here is 50, here will be 40. So watch out in case the angle of incidence is not between the normal and the incidence ray. If it is between the incidence ray and the outline AB, watch out for it. They used it to deal with last set for those in Unizik. Alright guys, so what have we succeeded to do here? I think our eye, let me bring out all the parameters or the quantities we have obtained. I'm trying to see that everything shows up, okay? Good. For this particular guy, I, that's this experiment now. I is equal to 50 degrees. R1, we got it to be equal to 31 degrees using this formula. Okay, these are Snell's law. R2, we measured it to be 29 degrees using our protractor. This is from protractor, measured from protractor. And then our emergent angle E, we got it to be 47 degrees. Our angle of deviation, we got it to be 37 degrees. If they ask you to evaluate D minus E, you do 37 minus 47, which will give you minus 10 degrees. Okay? But that is now based on your instruction. It is based on your what? Instruction. So take a look. Take a look at what I've done. This is how you construct without carrying out your life practical, so that for anybody that has problem with all this issue of pin placement and pin blocking, pin 1, pin 2, pin 3, pin 4, you can make use of this to be fast. Now, what is the final thing I want to talk about? When you manipulate this, yes, if you decide to do this construction, please remember that pin they will provide for you. Normally, you are supposed to have pin 1, pin 2, then pin 3 on the emergent tray, pin 4 somewhere here to block the image of pin 1 and pin 2 you will be seeing through this face. But now you are no longer doing that. You decide to construct, you decide to manipulate this. So you have to ensure that you are above blame, so that somebody will not look at it and say, this person constructed instead of doing the experiment, and then you will be failed. Yes, a strict examiner can discipline you on that. So you want to show that, okay, I did my tracing. And how do you do that? This is your incidence ray. Let me label it I ray. Let me label all these rays. This is I ray, incidence ray. Okay. Then this is emergent ray, E ray, emergent ray. This ray inside is a refracted ray. Sorry, I cannot be able to label it. This is a refracted ray. Look at it. I can't, so that I don't mess up inside. Okay. Good. These are the normals. This ray that went here is the incidence ray produced. Look at this one that went this way is the emergent ray produced. You can still go out if you want, but I don't want to produce it further. Okay, so use that pin, like I said, pierce this point, then label it whatever they ask you to label it. You can say maybe P1, then come to this point, pierce it, you can label it as P2. If in the experiment they use P and Q, fine. Follow their own label. Then come here, pierce it with your pin, and label it as P3, and then pierce here, label P4. Follow their own label, like I said. With this piercing, your examiner will assume that you actually carried out the experiment. Guys, I am done with this. Share this video to your friends, to your departmental WhatsApp group. Help someone out there. Help someone out there. There are many that are in need of this, so they can prepare for their examination. For students in Unizik, your phase 108 is taking place this week throughout, starting from Monday 20th, right? The Monday, what was the date of Monday? Monday is 21st. Okay, and I think until Friday also. So share this lecture video to your departmental WhatsApp group, to your friends. Let it go viral. Now, I've not been talking about like this video, leave your comment, appreciate it, leave your appreciation message. I decided not to be talking about that while I was making this video, because for me, getting this construction done for you, making sure I explain it accurately for you is what I was interested in. That does not mean that I am not interested in your liking this video, leaving your appreciation comment. I want you to do that for me, please, so that YouTube will recommend this lecture video to many people as well too. Okay, so this requires your likes, it requires your comments. Then help me and share this. Remember, GMAETS 41 continues to do his best for you friends. Okay? That's GMAETS 41. Of course, you have this for any who wishes to reach out to GMAETS 41. Don't forget you can become a channel member on platinum or diamond level. And of course, I'll appreciate that a lot. Thank you, and I wish you the very best in your examination. You can do it. What you're going to meet in the laboratory is simple. Yes, it's simple. Number one, you've run these experimental works since you started, your second semester. Am I communicating? So what you're going to meet in your exam is not different from the principles that guided what you did in your weekly laboratory works. So you don't need to be scared. Your exam questions are not coming from heaven. Although they are going to change different things, different batch is going to be exposed to, a little adjustment in principle. But at the end of everything, it still work within what you are expecting. Of course, you know that you are meant to prepare for triangular prism, rectangular prism. You're meant to prepare for lenses. Okay, that is a convex lens, which is converging lens. And then you're meant to prepare for your electricity. Okay, for your electricity, where you can use that voltmeter or ammeter as the case might be. On this channel, on this platform, if you go to GMAT 41's Physics 107 / Physics 108 playlists, Physics 107 / 108 playlists, you have the lecture video that will guide you through your examination on Physics 108. That's your physics practical. Make use of it so you can watch other lecture videos that I have there. I have a lot of live practical works, then of course alternative to practicals also. Once again, I wish you all the best. Like this video, share it to your friends, leave your appreciation comment. Remain blessed and success in your examination.